Good morning to all. Myself Esania, Assistant Professor, Department of Physics from Congo Arts and Science College. I'm going to tell you a topic of fiber optics. So, what is the introduction of optics? In 1870, John Tyndall gives the explanation of stream of water, which will be shown in diagram. After that, 1950, transmission of optical fibers was realized in practice. After that, Hopkins and Capney developed the fiber scope, which will be shown in diagram. So after that, Capelli coined the term fiber optics. After that, in 1960, light will be transmitted through the glass fiber. In 1966, Charles Coe and George Hopkins proposed the transmission of information through the fiber from one place to another place. After that, in 1970, Corning Glass Works produces a low loss glass fibers, which helps to transmit the information of light pulses through the fiber with low loss. After that, the glass fiber, optical fibers were used for commercial communication systems. So, what is the definition of fiber optics? The fiber optics is a technology in which signals are converted from electrical into optical signals and transmitted through the optical fiber, and again it will be reconverted into electrical signals. This is the definition of fiber optic. What is the optical fiber? An optical fiber is a hair thin cylindrical fiber of a glass or any transparent dielectric medium. It is used for optical communication system as a waveguides that will be made up of transparent dielectric materials as glass or a plastic. It is used to guide the visible or infrared light over a long distance. In this technology that transmits the information as light pulses through the optical fiber from one place. So what is the structure of optical fiber? This is the structure of optical fiber. This has a three layers, that will be core, cladding and then coating. So these are the three layers of the optical fiber. Next, first the core. Core is a thin piece of glass that will be located near the center of the fiber, which the light will be transmitted. It has the diameter of 8.5 micrometer to 62.5 micrometer. Next layer is the cladding layer. So it is a glass core surrounds the material on the outside, will be called as the outer material. During the normal operation, the outer material helps to reflect the light back into the core. It has a diameter of 125 micrometer. The lastmost layer is the buffer coating. This helps to protect the plastic optical fiber or a glass fiber from the damage. It has a diameter of 250 micrometer to 900 meter. So how it will be worked? The fiber optics transmits the data in the form of light particles or photons through the fiber optical cable. The core and cladding each have different refractive indexes that helps to bend the incoming light at a certain angle. That angle will be called as the total internal reflection. So it makes a zigzag path through the optical fiber. The light signals do not travel at the speed of light because of denser glass layers. It will be traveling above the speed of light. So this diagram explains how it will be reflected and then get at the output. So the path, this and this are the total internal reflections. It helps to reflect the light rays from one place to another place. Next, so with the help of these four elements, we can get the output pulse. So what one is the transmitter, second one is the optical fiber, third one is the optical receiver, and fourth one is the optical regenerator. The transmitter is helps to convert the electrical signal into a light signal, and then optical fiber helps to transmit the data through the medium, and then optical receiver helps to receive the transmitted light pulses. The optical regenerator helps to regenerate the light signals into the electrical signals. So why the cladding is necessary? So it is a necessary to keep light reflecting in core instead of being refracted, because we need it in order to pass on the destination from the source. So when light enters into a denser medium material into less dense material, it gets angle. That angle it will reflect back into core. So this is the reason the core is the denser and the outer layer is less denser medium. So the cladding maintains the uniform size of the fiber. It will protect the walls of the fiber from chipping and reduces the side of cone of light. So next one is the diameter remains to be constant through the element of the fiber, and then loss of light energy depending upon its surface, intensity factor, and then any dust particles occurs means it causes a leakage. From these all the elements, the cladding protects the physical damage and surface contaminants, and also it protects the leakage of light energy through the eminence base, and also it protects the leakage of light from the core to total internal. So what is the optical fiber cable? So this is the optical fiber cable which will be used in commercial. So this has the four layers. One is the water resist jelly casing. This is called as the core medium. After that, outermost layer will be made up of steel wires, and then copper duping, and then the high density polyethylene installations. One is a single mode and another one is a multi mode. This is a single mode optical fiber. This one is a multi mode optical fiber. So what is the comparison of single mode optical fiber and multi-mode optical fiber? So what the number of propagating mode will be only one in single mode optical fiber. In multi-mode micro optical fiber, it will be more than one. It has a core diameter. Single mode has a diameter of 8 to 10 micrometers. Multi-mode has a diameter of 50 to 62.5 micrometers. In single mode, the optical source will be a laser. In multi-mode, LED is used as an optical source. The bandwidth of the single mode optical fiber is more than multi-mode optical fiber. And the handling and coupling will be difficult in single mode optical fiber, but in multi-mode it will be very easy. Initial cost of fiber in single mode will be low. The multi-mode optical fiber has a cost of high cost. The attenuation losses will be more than more in multi-mode optical fiber and less in single mode optical fiber. The transmission distance will be long in single mode optical fiber, shorter period in multi-mode optical fiber. The numerical aperture will be high in multi-mode and low in single mode. The preferred fields, the single mode optical fibers are used in telecom and CAT networks, and then the multi-mode optical fibers are used in security LAN. So next, what are the classification of optical fiber? The optical fibers will be classified based on their refractive index, and then modes, and then materials. So based on refractive index, it will be classified into two types: the step index fiber and green fiber. And then based on modes, it will be classified into three types: step index single mode fiber, step index multi-mode fiber, and green multi-mode fiber. And then based on materials, it will be classified into three: glass, plastic, and then core. So classification based upon refractive index, it will be classified into step index and graded index fiber. It will be shown in diagram. So what are the parameters in step index and graded index will be given in the chart. The data rate of step index is slower and higher in graded index, and then the ray path of step index fiber will be total internal reflection, but in graded index fiber the light ray travels in a oscillatory motion, and then the index variation values will be given in step index fiber and graded index fiber. The numerical aperture will be remain same in step index fiber and will be changes continuously with the distance from the fiber optics in graded index fiber. So in normally plastics or glass preferred for step index fiber. Only glass will be preferred for the graded index fiber. So classification based upon modes of light propagation, it will be classified into two types: single mode SMF and multi-mode. So what is the single mode means? It has a smaller diameter, it will be propagate only one mode of propagation. But in multi-mode, it has large core diameter and it has number of modes of propagation. Next, optical fiber as an optical waveguide. So the light signals are transmitted through the optical fiber as a waveguide. So from that, we are giving an electrical signal from the microphone that will be goes to laser source, and that laser will be having a light pulses that will be transmitted through the optical fiber, and then it will be received by the photodiode, and then again it will be regenerated into electrical signals, and then it will be here on earphones. So what are the application of optical fiber? So one is optical communications and data storage. Second one, in military field and medical field it will be used. And then broadcast CATV systems and the fiber optics are used. A normal cable television on are used fiber optics. Networking, industrial, commercial and spectroscopic applications are used in fiber optics. What are the merits of fiber optics? So first one is a better bandwidth. It has a better bandwidth. The fiber optical cables have much greater bandwidth than the metal cables. Information can be transmitted per unit time of fiber over other transmission media, giving the fiber optic cables as a significant advantage. And with more and more business needing data transmission, it's become increasingly important to have high bandwidth availability. The second one is the higher bandwidth means faster speed. In our past society, our new normal is being able to upload videos, files, and make phone calls as we simultaneously download the contents. Slow internet connections can therefore cause business peaks of productivity. It is paramount that your internet connectivity is fast, efficient, and reliable to help keep your business as productive as possible. And then the third one is it has longer transmission distance. The optical fiber cable is low cost with longer transmission medium that you can achieve higher bandwidth over the longer distance. It maximum will be 100 meters of distance of copper cables are also available. The fourth one is it has a greater flexibility, and then fifth one it has improved latency. So fiber optic networks elements of many of latency issues. Users experience a cable internet, particularly when downloading or uploading a video or consuming high definition content. Stronger security, fiber optical keeps data secure. It does not radiate signal and very difficult to tap without your knowledge. So the advantages of optical fiber communication is the enormous bandwidth and the small size and weight, and the electrical isolation, the immunity to interference or crosstalk, and then signal security due to low transmission loss, and then system reliability and ease to maintain. Last one is the potential low cost. These are the advantages of the fiber optical communication. So from these merits and advantages, we are nowadays use optical fiber communication. Thank you.